Now, before starting work on set 2, please make sure that you have very close to hand a copy of your formula sheet. The two major rules we'll be making use of in this section are the sine rule and the cosine rule. The sine rule works on pairing, so A partnered with vertex A or angle A, side length B with B, and if you require it, side length C with vertex or angle C. The cosine rule, on the other hand, is a little bit like a hinged book. We know solid lengths and the angle between them. We don't know this missing length. So if I was after A, the square of A is equal to the square of B squared plus C squared. Take 2 times B times C times the cos of A. When I'm working with the angle, you can see B squared, C squared. Take the A squared divided by 2 times B times C. You will know situations when you're dealing with the cos of A because it's the only case we ever work with where we're dealing with side lengths only. Looking at 1A, this is clearly a case of where we make use of the side length relationship. So A squared is equal to B squared plus C squared. Take 2 times B times C times the cos of A. So in this case, we've got 12 squared and 14 squared as our two side lengths we know about. Now you can do that in one hit on your calculator quite readily. Now please notice that's far too big to be realistic, so I raise that to the power of 0.5, or take the square root, and end up with A 10.12 meters, or in this question, X. When it comes to F, we know the two side lengths and we know the angle between them. So carrying that through on my calculator, X squared is equal to 89.17. I'm taking the square root, raising it to the power of 0.5, gives me 9.44 or 9.4 meters. From there on in, from G onwards, you're looking at angle cases. The angle version of the cosine rule, the cos rule, relates the three side lengths. So if I'm after A, it's the square of B plus the square of C. Take the square of A divided by twice times the side lengths we know information about there, B and C. So taking that through to G, the cos of theta, the two side lengths, the hinges, 5 squared plus 6 squared, take 4 squared, divided by 2 times 5 by 6. Now I'll show you how you can do that in one go on your calculator. We make use of brackets. So the top line, the numerator, I'm using brackets for. Closing brackets, and divided by the denominator in brackets as well. So end up with 0.75. Now clearly that's not my angle. So shift cos will come up as default 41.4 degrees, or if you wanted to, 41 degrees and 24 minutes. When it comes to L, we're looking at an obtuse angle. So that's going to give us a cos value of a negative number. Now please don't panic. The calculator is designed to handle it. As a matter of fact, all angles of cosine between 90 and 180, but not inclusive, are going to be negative. So we can do this once again, one go on the calculator. Pays to practice this. Everything on the numerator has been kept in one bracket. So I get negative 0.2557, and hitting the cos to the minus 1 function, end up with 104.82 degrees, or if you wanted to, 104 degrees, 49 minutes.